Recording stopped. Recording in progress.
Right, so we are back now. Now we are talking about this EAR values and the recommendations RDA values, and without having the best understanding of these concepts, you cannot go beyond this. And if you cannot understand anything after this class, you need to read about the EAR values and the things, and there will be some essential references regarding this section, which I'm going to upload some papers to read, some publications. Difficult at your level to understand some of those things, but you need to read those papers and try to understand this concept. Remember that EARs are based on the data from a small group of persons. It's not the entire world population that we use to measure the EAR values. Right? So from the researchers, individual researchers' research findings. So it is a relatively small group of people. And also, we don't know the EAR values of certain nutrients. That means the population mean requirements are not known. And also, we don't know the standard deviations. We should know the EAR and the standard deviations. How can we collect all those data? By doing research. And then we need to see the distribution of in the population. And then we decide the EAR. And then we can calculate the standard deviation. Right? So, limited data to decide all those values. Different people need the different requirements, and we assume that there is a normal distribution, but normal distribution is not always valid for all nutrients. In other words, all nutrients do not have normal distribution curve that I have mentioned. All right. Some are skewed distributions. You know what is a skewed. So then this is the standard deviations, and the things can be changed. Some scientists said EAR is often extrapolated. Only, for example, we have ER values for young male adults. We have the EAR values because most of the dietary assessments were done using young male adults, and that is extrapolated, and the same value is we use for the females or for children, which is wrong. And in addition to that, very important concept that you need to understand, what we measure in the dietary assessment, 24-hour recall or diet diary, and then using the nutritional composition data, what we get is how much of nutrients we ate or we consume. It does not mean that same amount is absorbed into the body. Absorption is different. So without knowing the absorption rate, how can we decide whether we are getting enough nutrients? Now, for example, in Sri Lankan diet, we get most of our protein from rice, but that's not the best quality protein. More than that, we get the highest amount of iron also from rice, but that iron is non-heme, so then we can't absorb. So although the dietary assessment methods show that we get iron, that iron is not absorbed into the body. So absorption data from range of diet types limited. We don't know the absorption. Nutrient composition value values, you should understand that there are a lot of problems in the nutrient composition values. Nutrient intake data often not adjusted for usual intakes. Nutrient intake data collected by the scientists are not really usual intakes. Now, for example, if we do one 24-hour recall, two 24-hour recalls, you can't say it's a usual intake. Limited data on interactions. Some nutrients interact with some other nutrients. For example, you know that vitamin C enhance the absorption of iron, and the calcium interfere the absorption of iron. So then what's the interaction? Have we considered the interactions? Limited data about the host related factors. Host means your body, you. Some people can absorb, some people can't absorb. Some people, okay. Quick question to make you on hot seat. Questions අහනකොට තමයි ඔක්කොම කට්ටිය ටිකක් alert එකේ ඉන්නේ නැත්තම් නිදා ගන්නවා මෙතන. වික්‍රමාරච්චි WHS.
Yes, sir.
ඔයා නිදිද කියලා බලන්න කතා කරා. What's your first name?
Sanali.
Sanali. All right. Right. Okay, ඔයා නිදා ගන්න නැති බව මම දන්නවා. මොකද leader woman right. Okay, so I should ask a question from you. The question is Mama shock right. My question is we to absorb vitamin B12 into our body, we need a particular thing in our digestive system. What is that?
Sir, we need HCl and intrinsic factors to absorb vitamin B12 to the body.
Okay. The answer that I expected, intrinsic factor, that's an intrinsic factor. Different people have different abilities of secreting intrinsic factor. It's a factor. It's a factor means it's a some chemical in our body. So intrinsic factor is the levels of intrinsic factor of in different people is different. So then that's a host factor. It's a personal factor. Host factor means a personal factor. So person to person, different people absorb different amounts. Food to food, there is a difference in the nutritional levels, and also some nutrients interact with. So it's very, very complex. So you need to understand that there are so many problems. These problems we decide whether the certain amount of nutrients in your diet is adequate or not, right? This is also the summary of the data reference values, right? Now this is important table. Estimated average requirement. Estimated average requirement. Assess the probability that usual intake is inadequate. We can get an idea if you exceed EAR. This is the EAR for the population, and you calculate your the nutrient intake using your diet diary. And if this is here, this is your one. And if you exceed EAR, I can say that you seems to be okay because you are eating more than EAR. So you are above the population mean. So then therefore, the probability of not having the nutritional deficiency, the probability of not having a nutritional deficiency is higher. You have high chance of not getting nutritional deficiencies. But if your intake is here, then I would say that you have more chance of getting nutritional deficiencies. So here I can interpret your value, that's X or X compared to ER for individuals. For groups means I get your class mean value for a particular nutrient. Then I should compare this mean value with this EAR. EAR is also mean value of the population, and this is your population, and I should compare with this value and then interpret in the same way. Right? I can decide the prevalence of inadequate intake within a group. Prevalence. How many people eat more than EAR, or whether there's a higher prevalence of intake. So in other words, estimated average requirement can be used to get an idea about the population in your study or a survey. You do a survey and you get a mean value, and that mean value has to be compared with EAR, has to be compared with EAR. Right. It should not be compared with RDA. RDA you cannot compare this value with RDA. You should not, or you cannot compare. Make a note of that. We cannot compare the population mean value with RDA, but the population mean value should be compared with EAR. That's wrong to compare RDA. For example, I get the 40 dietary recalls from you, and I say calculate your calcium intake as 700 milligrams per day. That's not individual, that's a class average, mean value. 700 milligrams per day. Let's say your requirement, that's RDA value, is 800 milligrams per day. Your RDA value is 800 milligrams. As a class, you consume 700 milligrams. I should not compare that 700 with 800 and said that this class is deficient in nutrient, or you are not eating calcium, enough calcium. No, that is wrong. I have to compare this 700 with EAR value, that's the middle value of the given by the WHO. This is, let's say that this is 600 milligrams. So this class is consuming 700 milligrams. EAR is 600. So you are above the EAR. So then you have better chance of getting nutrient adequacies. I can later on calculate what is the proportion of people in this group has a risk of nutrient inadequacy. The proportion of individuals in this group has the inadequacy that can be calculated. If I know, what should I know? EAR I should know. I should know the individual intakes, and then I can calculate the mean intake. Right. Recommended dietary intake, RDA or RNI, should not be used for groups. That's what I said. This value, these are calculated value of the group, should not be compared with our RDA. Right? For example, another example, I do a survey with 300 school children in Pannal area and calculate estimate the calcium intake, and their calcium intake is 400 milligrams per day. That's a mean, but the recommendation is 1000. RDA is 1000 milligrams. I should not say that the recommendation is 1000 and this group consume 300, so then therefore this group has problems. No, should not be used. That is wrong. Lower reference intake, again I'm talking about this part, should not be used to decide the nutrient inadequacy. Right. Now this upper level of safe intake, adequate intake, there are different uses. But main thing that you should learn is you cannot use EAR to compare the mean value of this your study sample value should not be compared with you should compare this one with EAR but not with RDA value. RDA, in other words, on the other hand, this is important. Usual intake at or above this level has a low probability of inadequacy. Individuals, right? So Sonali's value, if it is less than RDA, then I would say that Sonali has higher probability or higher chance of getting inadequacies. So similarly, I can compare individual values with RDA. Now it should be clear. Individual values should be compared with RDA. Group value should be compared with EAR. And then justification why all those things are very scientific things. I will give you some extra readings. Some people may understand, some others may get a slight idea, but at least you should know, it is wrong to compare the population mean value with RDA. Simply, everybody doesn't have to eat RDA. I told you that in human nutrition. Different people need different amounts. So everybody in the population, as a population, you should not eat RDA. RDA is given for the population. RDA is given for the population, true, but RDA is given for a particular country considering individuals. So individuals should target RDA. You should target to get not EAR but RDA. But as a population, this class mean, if it is exceeding EAR, I'm okay. Right? We'll be fine when we are getting more examples. Right. Now, the next step is, after understanding this RDA, EAR values and your calculated value, how to assess the prevalence of inadequate intake within a group. Now, we have group data, right? So to calculate the group values, so then you look at the average intake of a group. We need to get repeat recalls or records. Repeated 24-hour recalls is a must. Number of repeat recalls depending on many factors. how many days of 24-hour recalls we have to take, that depends on the nutrient. Right? So for certain nutrients, more days. For certain nutrients, less days, less number of 24-hour recalls. I said certain nutrients you need 30, 40 recalls if you want to get an accurate estimation. Institute of Medicine, IOM, is an American medical research body, suggests 30 to 40 repeat for a group of people on 2 non-consecutive days. Non-consecutive days. Not consecutive days, but on 2 non-consecutive days, 30-40 repeats per group is required. Or 3 on consecutive days. If you are getting consecutive days, Sunday, Monday, Tuesday, or Friday, Saturday and Sunday, or whatever, 3 consecutive days or 2 non-consecutive days. Minimum 30 to 40 repeats per group, not 30 to 40%. That's I can ask how many 24-hour recalls I need to repeat in a survey, minimum in a survey, to estimate the usual intake of a group. Right. So without having repeated recalls, just using single recall or single diary, we cannot see the usual intake. All right. Incorrect methods for evaluating nutrient intakes. If you compare the observed intake of individuals using RNI as a cutoff, or compare the mean or median nutrient intake of group with RNI. Okay. Look at number 2. Compare the mean nutrient intake of group with RNI as a cutoff. This is wrong. Group mean nutrient intake with RNA is wrong. But you can compare observed intake of individuals and you can compare with RNI. So always individual values should be compared with RNI. Group values should not be compared with RNI. What kind of nutrients do we need? The 30, 40, 24-hour recalls like calcium and vitamin A. It depends on the variation. Certain nutrients, I told you earlier, certain nutrients we consume every day, energy every day, protein every day, but certain nutrients we don't eat the same amount every day. According to research, vitamin A, calcium, like nutrients, we don't eat the same quantity every day. Certain days very high amount, certain days very low amounts. So then to capture that, we need more days of recalls. So that's a good question, but I have already discussed that. Now you should have an idea. For certain nutrients, you need so many days. However, practically you can't do 30, 40 recalls from one person. So then therefore we decide we want to do 2-3 recalls maximum per person practically. Right. So certain slides the same things are given. Then so I skip some of those slides which you can read out later on. Right. Some of these things, right. This is an example comparing the methods for evaluating the prevalence of inadequate zinc intake, New Zealand. New Zealand, a particular island. New Zealand is not one country. New Zealand has so many the islands, and this is a study done in a particular island, and they selected 230 children between age 6 to 24 months, and their zinc intakes were calculated, and then they found that 60% of the population get RNI, and another 25% eat EAR. So majority, you can say that 60% of these children reach the RNI value, and 30% of the children reach 25% or 20, more than 20% of the EAR. More than 20% of the children reach EAR. So if you use the graph, right, if you use a graph, this is for the normal population. Normal population means healthy population. This is the EAR and this is the RDA. Right? So this side 50% and this side 50%. But this population is different, and it says reach the RN. Now in a normal population, 97.5% of the population should get RDA. But in this study, only 60% got RDA. So if I draw the graph for this population, it should be like this. It should be something like this. Sorry. Now here, in this graph, 97.5% of the population should reach the RDA. That's ideal situation. But in this population, only 60% reach the RDA. Only 60% reach the RDA, and only 20% reach the EAR. Now, usually 50% should reach the EAR. 50% in this graph. But in this population, the New Zealand children population, only 20% reach the EAR value. Only 20% reach the EAR. What does it mean? It means something like this. Graph like this. 20% reach the EAR, not 50%. So it has been shifted. This is not a very good population. That's what we can say. Ideally, 50% of the population should reach EAR. If not, it's like this. Many people are not getting EAR. Many people are not getting EAR. So in a question, if I give this kind of information and ask, what is the correct statement regarding this population? This population consume enough amount of nutrients or not? you should be able to judge. So I give you 1 or 2 minutes to understand this concept. Only 20% consume EAR in the green color graph, but in yellow color graph, 50% of the population consume EAR. That's the normal. That should be the normal. That should be the way. Right. Now, more things. Now, for individuals, individual nutrient intake, the correct method for assessing prevalence of inadequate nutrient intake in a group. In a group, now always think this as a group, 30, 40 students in this group. I have individual values. And now I want to know the probability of having adequate nutrients. So you can write it down. My question is, research question is, what is the probability of achieving the adequate amount of nutrients? What is the probability of achieving adequate amount of nutrients? That's a question. So then I want to do a research. So I ask everyone to complete 3-day diet diary and return it to me. And then I do calculations and then I get individual nutrient intake. So I get 40 different values. After getting all those 40 different values, now I want to tell you something about this entire group. Right? For that, I can use 2 methods. One is probability analysis. It's a shortcut method. We call it shortcut probability analysis. The second one is full probability approach. Right. How to do that? We take EAR as a cutoff point. It's called EAR cutoff point method. Right. Now, this is the EAR. Let's consider one nutrient. One nutrient, let's say vitamin C. There is an EAR value, we know that. How do we know? It's given by WHO. EAR values we take from WHO. WHO has defined for a particular population, this is the EAR value. These are the RNI values. So we take EAR values from the World Health Organization. Right? So let's say that it is 30 milligram vitamin C. 30 milligram is the EAR, just rough value. This is arbitrary value, not the exact value. And then I calculate the mean value of this class. Class mean value, that's X bar. And I want to check where is X bar, whether X bar is here or whether X bar is here. Depending on that X bar location, I can decide the probability of inadequacy for this population. Population is your population, this class. This is called EAR cutoff point method. I compare with EAR. I said that the group means should be compared with EAR, not with RDA. I'm not going to compare your value with RDA. Right. And there is another method called full probability method. For that, you need to do several steps of calculations, and you need to use some computer software. Then it's easy. And particularly, this is used for nutrients with skewed requirement distribution. Skewed requirement distribution. Skewed requirement is something like this. This is something skewed distribution. For example, iron. Iron in the population is not normally distributed, not bell-shaped. Iron requirement of the population is skewed. Right? So EAR is here, maybe here. No, EAR is the defined as 50% of the population, so maybe here. So 50% here, 50% that side. Right. So in for such nutrients, we have to do the full probability approach, definitely. Look at this bottom line. Both predict more reliably the number of individuals within a group with nutrient intakes below their own requirement. Our problem is, what we want is, we want to know how many individuals in your group consume below their own requirement. And I have the population mean. Let's say that I have a population, I do a large sample study in Sri Lanka for preschool children, less than 5-year-olds. I get a mean value of the intake of calcium. Mean calcium intake of 1,000 children in this country, less than 5-year-old. I should not compare it with RDA, but I compare with EAR. That's EAR cutoff point method, and it's a calculation method. And there is another method called full probability approach. By doing that, we can get an idea how much of the Sri Lankan preschool children population consume enough calcium or not consume enough calcium. That can be decided by looking at these two methods. Adequate or not. That's what we want to tell the country, whether our children are eating enough calcium or not. That can be decided by two methods. One is called EAR cut point method, and the second one is full probability approach. These are more mathematical applications, or sometimes we need to use the computer software called PCSide. Right. PCSide, we recently started using PCSide software, and it gives the value. Okay, in Sri Lankan population, preschool children, according to your data set, this much of a nutrient inadequacy. So then we can tell the health ministry, country, the nutritionist, this much of nutrient adequacy has been reported among children or the adults or elderly, something like that. Okay? So the probability approach and the EAR cut point method are the two methods that we have to use to decide the nutrient adequacy. You will understand this after reading a little bit more, but the reading materials are also difficult to understand 100% unless you have a good statistical knowledge. Right. Now I'm going to show you some more graphs. Look at this graph. So I explain. First, when you see a graph, look at the x-axis and the y-axis. Y is frequency of intake and the x is intake levels of a particular nutrient. Right? 0, 60, 80, 100. These are not standard deviations. These are just the intake levels, micrograms or milligrams or something. Now this is the mean value. Oh, sorry. Right. So this is the EAR value. This is a little bit skewed one. Intake of 100. Right. This is the EAR. 100 is the EAR. This is the shade. This population is, you can't say definitely they have deficiencies, right, but their usual intake is below the EAR. This is the proportion of individuals in the group. This is the proportion of individuals in the group whose intakes are below the estimated average requirement, EAR. That must be clear to you. Right. Non-shaded area is a proportion with usual intake above EAR. Right. How many people eat above EAR and how many people consume less than EAR? I can decide. If I have the EAR value, if I have the different individual values, I can decide or I can calculate the proportion of people eating more than EAR and proportion of people who are eating less than EAR as a percentage. That must be clear. If this is not clear, please ask now. We said this group is at risk and this group is not at risk. This is what we call EAR cut point method. If the EAR is 100, we can decide proportion of people at risk and the proportion of people not at risk. Remember, and somebody might ask, hey, EAR should be in the middle. No, this is your population. This is not the population used to calculate EAR. This is your population. Right. Now I am going to ask a question from everyone. Right. Tell me whether this group is a better population or performing better or performing adversely, or is this a better performing group or less performing group compared to their nutrient intake, considering their nutrient intake compared to a normal population. Say normal population is any normal healthy population, very normal healthy population compared to a normal healthy population. Is this group doing well or not doing well? That's a simple question. Compared to a normal population, is this group doing well or not doing well? Right. So the answers. And why you said that this is not doing well or doing well? Nimesha. Yes.
This population is not doing well.
Hey, Nene.
This population is not doing well.
This is not doing well. Why?
They didn't reach normal population average ERC.
I can't get a clear. Your voice has a lot of maybe problem in your microphone. Say it again.
It is not reach normal population EAR level.
Not achieving the normal population EAR level. Okay. And let's try another person. Shivanti.
The population is not doing well because here the EAR has not reached the 50% of population.
Right. 50% of the population does not reach EAR according to this graph. Shehari.
Yes, sir, I thought the same thing.
Right. Udan.
Yes, sir. I thought that this.
So the population, how many of people in the population should reach the EAR?
50%.
50%. So then this group, 50% has not reached the EAR.
Yeah.
Mm-hmm. So where is EAR? It's here.
Yes.
EAR is 100. So 50% of this group has not reached 100.
50% reach 100, but not 120.
120, what is 120?
It is the reference ER.
No. This is the reference EAR. Reference EAR is 100, I said. This is the population mean. This is this population's mean. This is EAR. So all three or four answers given are completely wrong. So that means you need more thinking. I can't do it. I can't spoon feed everything in the class. After the class, you have a lot of work to do. Right? EAR is here, 100. And here you see that most of the people eat more than EAR. Most of the people, more than 50. Only a small portion of people eat less than EAR. So this is a very good population. Better population than normal population. So all your answers are wrong. Understand that. You can question this. So here it's very clearly said, at-risk population, you can, by looking at this, you can see that at-risk population, shaded area, less than 50%. In a normal population, so if I draw the graph for the normal population, it should be something like this. This is here. So then in a normal population, 50% is 50% is inadequate amount. But here, only look at this, the shaded one. In a normal population, 50% of the people have less than EAR. But in this population, look at that, less than 50%. Lesser proportion is having, yeah, so this is a better population. Right. So then next week when you come to the class, you should have a better idea, and otherwise you cannot interpret the survey data.
Recording stopped.
Right. So you need to read this and get a better understanding about EAR values and the things like that, and also I provide some reading materials already, maybe the LMS. Let me check. Okay, I need to log into that. Okay, so in the next week, so then there will be a quiz based on the 6 different dietary so did I have a quiz earlier with you or not?
No, sir.
No. Okay, so this is the quiz. Just concentrate on the different different dietary assessment methods and their advantages, disadvantages, accuracy, which one is more accurate, some practical points in doing them, which one is better for usual intake, which one is better for a large population. So all those kind of things you should have, and there will be 20 MCQs that which you need to answer within 20 minutes using LMS. 20 or 15 MCQs I will give. So then 5 minutes, 5 marks for your final assessment will be taken from this 5 marks. So don't lose 5 marks, and I can't do makeup exams unless you are really sick, or then you need to prove or give some evidence that you are not well. And then all those other exercises you should have completed, your diaries and the things like that, and then you are continuing your food composition table. Those things I'm not going to ask main questions about the food composition tables in this quiz. This is only about the dietary assessment methods. Which method is best and which method has so many these things, and what there may be true and false questions, something like that. Are they clear? It's okay? Any questions? Anything? Any worries? Sanali, any questions? Any worries about these arrangements?
No, sir.
So far, okay? Right.
Yes, sir.
Right, okay. Right. So then I stop for today, and we will meet next week, Tuesday morning.